Okay, so we're going to get a little bit into why do we actually go through and factor, why we spend so much time looking at different equations and factoring them. We're going to go through kind of two reasons that you might factor for right now. One of them is kind of a preview of things that we may get to at the very end of the year. It's more of an Algebra 2 skill usually. And the other one is what we'll be using a lot. So the first one here, to make complicated quotients simpler, it's actually a process that you're familiar with regarding numbers. So right now, you've got two pretty large numbers, 1848, 5,544. One way, when you first talked about simplifying quotients, simplifying fractions, was to write out the factors. So obviously, doing a factor tree on these numbers would be a long process, but we went ahead and did it for you. But to simplify the quotient, so we took the factors here, and now to simplify this quotient, all you can do is look for common factors and cancel them out. So 7 and 7 cancel out, 11 and 11 cancel out, and you make that quotient much, much simpler. I would much rather look at 1/3 than 1,848 over 5,544. Same thing can be done with polynomials. So for instance here I have two simple polynomials, two simple quadratics. Same idea, factoring them. So the numerator is x plus 7, x minus 7, because that's the difference of squares. And the denominator, if you went and did the cross puzzle and everything, it would be x plus 7, x plus 1. The idea again, how can I simplify this? I can cancel out common factors. So leaving me with a simpler quotient in the end. So this is one use of it, and like I said, this is more of a preview, just giving you a couple of different options. What we're really going to be using, though, factoring for is for solving equations. So before we get into the polynomials, what we're actually going to look at is a rule here that's what's going to help us to solve polynomial equations, and more specifically, we're going to be working with quadratic equations. When we talk about solving each of these equations here, we're trying to find the value of x. You have 5 times x is 0 here. You have x times 278 is 0. For either one of these two, I would think it should be pretty obvious that the only way you're going to get 5 times 0 or 5 times x to be 0 and x times 278 to be 0 is if x itself is 0. So for the second equation here, if we have x times y equals 0, you got to think, okay, if I'm going to get 0 as a result, what has to be true? Here we have two variables. So what would be true here is that either if x is 0, this will work out, or if y is 0, that'll work out. This idea actually leads into the big kind of piece that holds together how we're going to solve equations using factoring, and this is called the zero product property. If the product of two quantities is 0, so multiplying two quantities gets you 0, then one of those quantities, so in this case either x or y, has to equal 0. So how does this help us when it comes to factoring? Well, think about what factoring is. Factoring is breaking our polynomial or number down into its products, what multiplies to be that polynomial overall. So this is my I do. If you had a polynomial and you factored it into x plus 3 times x minus 5, the zero product property says if a product equals 0, a product of two things equals 0, then one of those items, if you look back, one of those quantities has to equal 0. So either, because I have a product here, either the first quantity has to be equal to 0, or this second quantity has to equal 0 in order for my overall product to be 0. So what we're looking for here is what x values will give me a value of 0 in the end. So what x values? Well, I've set up two linear equations that now I just need to solve. So x could equal -3, add 5 to both sides, or x could equal +5. So if I look at my original equation, x plus 3 x minus 5 equals 0, I'm saying either one of these answers could be the solution. So if I plugged in -3, -3 plus 3, -3 minus 5, that would be 0 times, and it doesn't matter what goes in this space, it's -8, but it's going to equal to 0. Same thing with the 5. If I plugged in the 5, I'd get 5 plus 3 times 5 minus 5. So this part equals 0, so it doesn't matter 8 times 0 or whatever you're multiplying by, it gives you 0. So there's two possible answers because there's two different things, two different quantities that could equal to 0. So that's my I do. Now you're going to try it using the zero product property. So pause and try this one. But the idea is either 2x minus 3 equals 0 or x plus 7 equals 0. One of those two quantities has to equal 0. So either x is, and I'm just going to solve for x, either x is 3 over 2 or 1.5, or if I subtract 7 from both sides, x is equal to -7. So x is 1.5 or x is -7. One of those two quantities has to be the value of x in order to make this work. So what you may be wondering about is, okay, well, the zero product property, what if, and actually I'm just going to go back here a second, what if instead of the zero product property, what if on that side the equation said x plus 3 times x minus 5 equals 6? It's really important that we do have the zero product property, that we use that zero. The zero is the essential piece here, because if you think about it, when we have something equal to 0, we know that one of those quantities, one of them has to equal 0. If we're looking at, if we have a different number here, the problem is that any number of factors, if you're thinking about this as something times something else, so this parentheses will give me a number, this parentheses will give me a number, and it has to equal to 6. The problem is we could fill in those blanks with lots of different things. It could be 2 times 3, it could be 3 times 2, it could be 1 times 6, 6 times 1. It could be fractions, 1/2 times 12. It's really essential that we use 0 because we want to make sure, because it's the only way we can really narrow down that one of those values has to be 0, that one of these quantities in the parentheses has to equal to 0. So anyway, back to solving these and setting these up. Using the zero product property, the first thing you want to make sure before you do any other work is that one side of your equation is equal to 0, because what we just talked about. So now I'm looking to say, if I'm going to use a zero product property, I want to see what products are equal to 0. In other words, I need to factor the quadratic, or factor the problem that I have. So to factor this, I'm looking for what multiplies to be -18 and adds to be +3. That would be 6 and -3. Because it's just x squared in front, I know that I can make +6 and -3 the components of my factors here. So now the zero product property says either x plus 6, either x plus 6 has to equal 0 or x minus 3 has to equal 0. So subtract 6, add 3, x is -6 or x is +3. So zero product property, one of those factors has to be equal to 0. Now it's your turn to try it. So you want to factor any way that you possibly can. We have 0 on one side, so now we want to try and factor any way we can. There's only two terms here, so we really want to start with our first step on any factoring, which is GCF. The GCF here is x. What am I left with? X minus 3 And can I factor that anymore? The answer would be no, because this is not a difference of squares. There's no factors in common anymore. So what I want to say is, what's multiplying together? X and x minus 3. So either x, the first quantity equals 0, or the second quantity equals 0. So add 3 to both sides, either x equals 0 or x equals positive 3. So one of those two values. So generally speaking, the two things you want to keep in mind: the 0 on one side of your equal sign, so you can use the zero product property, and then the factoring of your, generally speaking, quadratic. You notice a pattern here. We're looking for two different answers. So generally two different possibilities, or two possibilities, and maybe not always different. But that power right there, and you'll get to know this more as you go in through Algebra 2, that power right there tells me I'm looking for two quantities. So I want to do one more problem, and I will leave you with one to do on your own. But the idea, again, with the zero product property, you want to make sure one side is equal to 0. This side, now we have an equation where one side is equal to 7. So before you factor, before you do any extra work, you want to make sure your first step is get one side equal to 0 in your equation, so that you can use the zero product property. 2x squared minus 13x minus 7, because none of those were like terms. And I'm just going to go ahead and factor this. I know you could go through the whole process, but I want to kind of get through this a little more quickly. So once you have one side equal to 0, now you can go ahead and factor, and then there are your two products. So either 2x plus 1 equals 0, or x minus 7 equals 0. So solve for x to get your two values. 2x equals negative 1. So x equals negative 1/2, or if I add 7 to both sides, or x equals 7. So 0 is your first priority, and then factoring. So actually I'm going to give you the you do, and you can pause it and try it, and then we'll go through it. I thought we weren't going to have time, but we will. So go ahead and try this one on your own. So using the zero product property again, we need one side of the equation to be equal to 0. It doesn't really matter which side of the equation, so my tip to you is to always try and make that a value, that first term, positive. So I'm going to subtract 6x and 8 from both sides to get the left side equal to 0 instead of the right side. It doesn't matter which side, and if you did the opposite, you could still get to this correct answer. So what multiplies to be negative 40 and adds to be negative 6? That would be negative 10 and positive 4. So 5x squared minus 10x plus 4x minus 8. So factoring this, go ahead and group them. 5x, and that's x minus 2, and that's positive 4, and that's x minus 2. So my parentheses are x minus 2 and 5x plus 4. You can see how these problems could turn into a little bit of work, for sure. But if we make both of these parentheses, x minus 2 equal to 0 and 5x plus 4 equal to 0, then we subtract 4 and divide by 5. X is negative 4/5, or add 2 to both sides, x is equal to 2. So we'll practice more of this solving. But the idea, again, most important things. First thing, make sure you have one side equal to 0 so that you can use the zero product property, and then you want to factor. You may use any method of factoring that is possible.